This is a demo for lab 5. In this lab, we're trying to emulate a microprocessor on an FPGA using system Verilog. The interaction with the program is going to be with switches 0 to 4 and the key 0. Switch 0 resets the program. Switch 1 allows us to go into step mode. And the combination of switches 2, 3, and 4 will change the display, varying from a program counter to opcode to ALU, the value that's in the ALU, to the name of the student, my name in this case. When switch 1 is on, key 0, pressing on key 0 allows us to move through the different state of the program. Typically, the requirement was to clock it at about 1000 Hz, but it was too fast, so we slowed it down. In automatic mode, it runs about 7 to 8 seconds and to completion until the program hits a halt command. So let's start with the automatic mode. All I have to do is just flip the switch 0 from reset to on, and wait about 6, 7, 8 seconds, and now it's done. So it went through the list of the program, which is already in the ROM, and it finished. At the opcode halt, which is basically if we so now let's look at the display. The display is showing my name, which basically the switches 4, 3, and 2 are all in off position. If we put all the switches in on position, we're gonna see the opcode, and in this case halt, which basically the last instruction of the program. If we flip, if we use switch 4 and 3, we can see that we go into the program counter. This is the program counter in hexadecimal. It's 14, and also the LED show the program counter. So the first LED is 2 to the power 0, 2 to the power 1, etc., etc. So it's 0, 0, 1, 2, 4, 8, and 16. So we're 20 decimal, which is 14 hexadecimal. So this ends the first part of the demo. The second part is we're gonna do the same thing, but we're gonna go step by step. So let's put switch 1 on, turn off all these switches, reset it, and then go back. And now let's go to so any combination that are not allowed, the display turns off. For instance, switch 2 being on and switch 3 and 4 are off is not an allowed option, so it turns off. So in this case, let's switches 2 and 3 are on now, which is basically now we can see where the counter is, and we are at the first instruction in the ROM memory at 0, 0. So now if you press this, probably nothing's gonna happen because we're cycling through the different stages of the microprocessor, which are basically the first stage, the cycling of the microprocessor, which is the first cycle is the instruction fetch, and the second one is the instruction decode, the third one the data fetch, the third one execute, and the last one is when we the result write back, where basically the result of the ALU is written back to the RAM, in this case our rec file, or makes a jump, either conditional or non-conditional, to the program counter. So now we are at instruction 1, and we can see now let's see what the opcode of this instruction, and it is LDI, which is a load immediate. So this is the LDI, this is the instruction, and this is what's in the ALU now. There's 0, 1. Same thing as and now if we press 1, 2, 3, 4, 5, we go back. We're now in instruction number 2. Again, it's still an LDI. The first 4 instructions are LDI, so it's going to be the same thing. The difference is that the third one we might probably see a different result. So this is LDI. Let's switch to what's in the ALU. It's 0A, which is 10. So now go back to instruction 3, instruction 4. I know that instruction 4 is different, so let's see what's in instruction 4. It's a compare jump. So the program is going to compare two values, and if the first value is greater than the second, makes a jump, or not. If not, it just continues, which in this case I know it's going to continue. Went to instruction 5, which is an add, and then let's go back to, and I know it's gonna cycle because 7, 8, let's see, 8 is an increment, and I know it's gonna go back to 9, and then it's gonna jump back to 4, and then go back again, 5, 6, 7, 8, hit 9, and then jump back, and it's gonna do it many times. So that's why, so here we have ADI, this is what we have in the ALU. So let's flip it a little bit more, advance it, and then stop here. Let's see which, because at least 2/3 of the program goes into this loop. Yeah, let's do it again. All right, so now we are at instruction C, and if we take the instruction sheet here that we have, we see that instruction 0C is a multiply. So let's see if it's really a multiply. So if you flip this button, we know that it's a multiply. Then we can go to D, and D, so C, because here there are no more jumps, so it's gonna go linear. So D is a sub. Let's see if it's a sub. It's a sub. And then we can continue. Let's go to 11. Let's see what we have. 11 here. So 811 is XOR, exclusive OR. Let's see if this is correct. It's XOR, but since we don't have too many, we emulate X with H and R with the little r, so that's XOR. And we can go back. Let's go see what we have in 12. In 12, an AND. Let's see, do we have an AND in 12? So 12 is an AND. And what's in the, let's check, see what's in the, so that's 12, and that's what we have in the ALU. Now it executed, it went from F5 to F7. And now if we, I'm sorry, and now 1, and now it's gonna jump to 13, and in 13 we should have a comp. Let's see if this is correct. So we have a comp, and then after that 14, and then whatever we do, nothing happens. Let's hold, it's finished, and it's done. Well, that's my program. Thank you.